Hey everyone, it's Charles here. So this is the first lesson, I guess, in the series I'm gonna call High School Math Fundamentals. This is for my legacy project in for Mr. Visconti's class, and I figured, you know, since I want to, like, since I'm good at math and I want to help the community, I figured I'd try and help some of you guys who might need some help, right? Instead of maybe looking at Khan Academy videos, you can get a personalized experience from an actual student at O'Connor here. So I guess without further ado, let's get started with substitution and elimination. So let's conjure up a line here in the form y equals mx plus b. And let's come up with an example here. Let's say y equals 5x plus 7. Okay, and then we'll get another line or another equation. We'll say even 3y plus 5 equals a third of x. And that's just like 0.3 repeated multiplied by x. And so we want to solve for x and y, right here. So we want to find a point at which these two lines here, because these two equations both represent lines. And we want to find the point at which these two lines intersect. And in order to do that, we're going to use one of two methods. So we'll start with substitution. All right. And let's label our equations here. We'll say this is 1 and this is 2. So equation 1 and equation 2. So if we're going back to equation 1 here, we see we already have y isolated, right? We know that y is equal to this, right? So what we can pretty much do is we can sub this in to the y here. Since we know that the y in each equation is going to be the same because we're finding the point at which two lines intersect. This is not what the actual lines might look like, but if we have two lines here and they intersect at this blue point here, the x and y component of that point there is going to be, it's going to belong to both lines here. It's the only point at which these two distinct lines are equal, right? They have the same x value and the same y value at the exact same time. And so let's substitute it now. We're gonna write out, so we're gonna do 1 into 2. And so equation 2 here is 3y plus 5 equals a third of x. And so we're gonna sub in whatever this was, this 5x plus 7 here, because we know that's equal to y in our first equation. So I'll make this pink here. And so that's 5x plus 7. It's going to be the exact same thing, so I can literally just copy it and move it here. Right? Plus 5 equals a third of x. Right? And now we only have one variable here. We're progressing, right? So let's expand this and solve for x. So this is going to become 15x plus 21 plus 5 equals a third of x. This 21 and this 5, you can collect those terms. So 15x plus 26 equals a third of x. So I guess let's move this x term to the other side. And to do that, we're going to subtract 15x from both sides. 15x plus 26 equals a third of x, and we're subtracting 15x from both sides so that this and this will cancel. So now we have 26 is equal to a third of x minus 15x. 26 is equal to a third of x, and we're gonna get this 15 in terms of we're gonna get a common denominator here, so we can subtract the coefficients essentially, so we can like collect the x term. So we're gonna do 15 times 3 over 3, because that's the same thing as 15 over 1, or just 15, because the 3's would cancel, but we don't want them to cancel. So that's a third of x minus 45 over 3x. So 1 minus 45, that's negative 44, so it's negative 44 over 3x. That's 26. And now to isolate for x, we're going to multiply 26 by the reciprocal here, because the only way we're going to multiply both sides by the reciprocal of this fraction, sorry. So 26 multiplied, and you see why that works in a second. 26 multiplied by negative 3 over 44. The reciprocal just means flipping the fraction upside down. Equals negative 44 over 3x multiplied by negative 3 over 44. Right? Because what you do to one side, you must do to the other. Right? Or else the equation becomes false. Right? So 26 multiplied by 3, we're going to have in our numerator here, over 44, and that's negative. Equals, so the negatives will cancel out, the 44s will cancel out, and the 3's will cancel out. So all we're left with is x. So that's x. And let me just punch this into my calculator and see what we get really quickly here. So that's 78 over 44. And that can be simplified. 78 divided by 2. So negative 39 over 22. And I believe 39 is a prime number. So yeah, that's it. We found x. But that's not completely it yet, right? We still have to find y. We're finding a point, right? X is not enough. So we're going to take this negative 39 over 22 and then sub it back into any one of our equations here. Any one of our original equations. It doesn't matter which, so I guess whatever's easier. And I like this first one more, so we're going to sub it back into this first one. Let me just grab it from here. Copy, paste. And you'll see this does get kind of lengthy sometimes. You know, maybe you won't have to show this much work every time. Not every teacher expects the same thing. But in general, it is kind of like a safer option to show your work, and I'm doing it here so that you actually have an understanding of what's going on, and you're not jumping straight to the answer, pretty much. So let's sub that in for x here. So y equals 5 times negative 39 over 22, because that's x. We just sub that in for x, plus 7, right? So 5 times 39 over 22, and that's negative, plus 7. So y equals negative 5 times 39, 195 over 22, plus 7 times 22 over 22. So we're going to get negative 195 over 22 plus 7 times 22, which is 154. That's over 22. And then finally solving this here, it's 154 minus 195 negative 41 over 22. Can this be simplified? I don't believe so. So, yeah, now you have your x and your y here. So now you can put a conclusion statement saying, therefore, these lines intersect at the point, so that's our x, negative 39 over 22, negative 41 over 22. Right, that's our point. Okay. And yeah, that was a little lengthy, right? So we're gonna try another way of doing the same problem now. It's gonna be elimination. Right, because it's substitution and elimination we're doing. So we're gonna copy these two here. And essentially what we're going to do is we're going to either subtract or add these equations together in a way, right? So first I'm going to get rid of this 1 over 3 because it's kind of ugly. So what I'm going to do to this second equation, so that's 1, that's 2 still, I'm going to make that... So it's 3 times 3y plus 5 is 3 times a third of x. So it's going to be x on that side because that and that will cancel. This is going to be 9y plus 15 by the distributive property. Okay, so we have two equations now, right? And they kind of look similar in a way, right? But I'm going to try and get this y term by itself. And you'll see why in a moment. So 9y equals x minus 15. Bringing that over to the other side there and changing the sign. Subtracting 15 from both sides. And so now we have... This is as equation 2, and that as equation 1. Let's turn this back to black. So we can eliminate one of the variables here. So we can have, we're going to isolate for y here, x over 9 minus 15 over 9. Because I'm just dividing this by 9 and this by 9. Right, so now we have that equation. And this one up here. Copy, paste. And what we can do now is we can subtract these two equations, essentially. So I'm going to just get this one here. Paste. Okay. So we have these two equations, right? And since the sign of... So, okay, in this case, we're trying to eliminate y, right? Because the coefficients are the same. That means we can eliminate it. If the coefficients are the same, you're going to be subtracting the equations from each other, right? If they're equal but opposite, say this was 5y and this was negative 5y, you'd be adding them because 5y plus negative 5y is 0y, or just 0. And that's the point. We're trying to eliminate it. We're trying to make it 0. Right? But in this case, we're going to subtract, and you'll see why in a sec. So we have this equation minus this equation. So how do we subtract two equations, right? We are gonna say y minus y on this side of the equal sign, the left side. That's 0, right? Y minus y is 0. Pretty straightforward. And then here we have 5x and x over 9. So we're going to have 5x, and then we're subtracting minus x over 9. Okay, and then we have our 7 and our negative 15 over 9. So we are going to add 7 minus negative 15 over 9. Because that's the next term in this binomial here. Well, this is not a binomial right now, but it will become a binomial once we simplify it. So we are going to collect our like terms here. So I'm going to say 9 times 5x over 9 minus x over 9 plus 7 times 9 over 9 plus, because if you're subtracting a negative, it becomes addition, 15 over 9. So 9 times 5, that's 45. That's x over 9. Plus 7 times 9. 7 times 9, I believe that's 63. 63 over 9 plus 15 over 9. And this is all equal to 0, by the way. So now we have 44x over 9 plus 63 plus 15. 63 plus 15 is 78 over 9. Okay. And this is all equal to 0. So now we can literally just solve for x now. So we're going to move this to the other side. Or in other words, we're going to subtract 78 over 9 from both sides. Because what you must do on one side, what you do on one side, you must do the other. So negative 78 over 9. 44x over 9. Okay, so now we have a common denominator here across like both sides of the equation, so we can cancel it. Negative 78 is equal to 44x. Right, then just divide both sides by 44. And they cancel, so that's x, negative 78 over 44. And that simplifies to 39 over 22. And look at that. It is the same answer we got in the previous method there. So yeah, that's pretty cool. It's just another way of doing it. In this case, it's about the same amount of work, but sometimes one will be, noticeably easier to do than the other. So let's do the same thing now that we did here. I mean, this last step is honestly just the same as the substitution method. And I'll highlight these. Right. So it's going to be the same thing here, and you're going to get the same answer because you're plugging it into the same equation, and so you're going to get the same conclusion here. And yeah, that is substitution and elimination in a nutshell. Thank you for listening.